Hello, I am the High Lord Trevor Aparicio.
I am Jedi David Page.
I'm Colonel Harrison Williams.
And I'm Vice Admiral Daniel James Steffi.
And this is our presentation on functional versus imperative languages. First, we'll start off with the imperative side. This is the most commonly used form of programming languages, and such languages include C, C++, Java, etc. These languages all prescribe what to do for the computer. They use step-by-step procedures that tell the computer exactly what it wants to do and exactly what steps to take to get to the end result. In order to do this, such programs use if structures, for loops, while loops, functions, classes, and objects. Now, the functional side of programming languages. These languages, instead of describing what to do to the computer, they describe the end result and how the end result is supposed to look. So it's what you want as the programmer. Languages such as Scala, Haskell, Lisp, Scheme, and OCaml are all at least partly functional languages, and they use function calls, higher order functions, and recursion to accomplish their tasks. Now, a quick example of the differences between these are directions versus addresses. So if you have somewhere that you want to get to, and you're given specific directions, there is a to place and a from place that the directions are based on, and you can't change that. However, if you're given an address of the place, then you can look up on Google Maps or some other mapping program to figure out your own to place or your own from place and get there however you want.
So next we're going to be talking about the pros and cons of each language. The imperative language, it's really easy to know what's going on. You can just take a look at the physical code and say, oh, I know what's happening in this section. It's pretty easy to debug because you can do it stepwise, so you can just take each bit of code and go step by step through that function, through that program, and determine what's wrong. It's really easy to define objects, such as you can define a person, which has a bunch of different attributes about them, such as a name, a birth date, an age, and it's really easy to perform functions on those objects in the imperative language. There's also state variables, which are variables that are hold true throughout the entire function. You don't really get that with functional programming, as the variables change inside of each recursive call. With functional, the pros on that are pure functional languages have no memory or I/O side effects. Languages now are impure, so they have little memory or I/O side effects. There's a lot less code, which is due to the fact that you're recursively calling or using multiple functions, so it's much smaller snippets. It scales really well, so you're going from like a smaller function to a much larger scale project, such as Twitter. It's pretty easy to use. And higher order functions are very easy in functional programming, which is using a function as either an argument or a return value of that function.
Now, looking at some cons for the imperative side, the imperative programs usually result in lengthier code than their functional counterparts. This is because of how imperative goes through each step of what needs to be done, and especially at higher scales, you can see imperative having much greater amounts of code in it, which can actually result in harder debugging if there's too much code there to try and figure out where something's going wrong. So because of this, you could say that it scales poorly, and also such things as arrays having limited sizes, and if you're putting them on multiple systems, having to allocate memory for the arrays of huge sizes, it doesn't scale very well on large scales. And it's difficult to multi-thread imperative programs to make them run faster. And now for the functional cons, simple calculations are slower than their imperative counterparts. It's harder to understand code for most programmers, which means that using functional in the workplace where with other people, it can make it more difficult to show to other people and have them know what's going on and have them work on your code and so forth. And it's got a sharp learning curve as compared to imperative, so it's harder for people to get into it, to understand and be able to write its code.
Now we're going to give a few examples of functional versus imperative languages. We're going to start out with the functional languages examples, and we're using Scala as our functional language. To start out with, we've written a quick snippet of a Fibonacci code, and it finds which step, whichever number is the latest step that you want. And as we can see, it calls recursively with our Fibbo helper function, and the argument for our Fibbo helper function is actually the description of what it is that we want to find in the end. We want to find the 10th case, which is our n-1 situation, and we want to know what a plus b actually results in on each step. And so when we do this pattern matching and run through the program, we end up sort of describing what it is we want to get to from our base case to our final case, rather than what we're going to do step by step. Our next example is in Java for our imperative language. And in this case, you can see there are some key differences. We start out by describing with state variables what our starting cases are, and then we also describe step by step what we want to happen with a for loop. A for loop is an example of giving implicit directions of what you want to happen, rather than sort of describing the overall case. And in this case, we show that we want to add A to B every single time, and we want to subtract A from B, or B from A, sorry, every single time, and find out what the output is going to be. And if we run both of these programs, we'll find that they give the same output, which should be 34. And then if we switch over to the Scala side, we can run this one as well. And we will also see that the resulting number is 34. Now if we look at the Scala version of our factorial snippet, what we can see here is, again, we have pattern matching to figure out where we are in each step, and we describe our base case, which is where our case 1, and we describe how we want things to end up looking through our factorial helper. Again, what we're doing in this case is we're using recursion and pattern matching to sort of describe the overall goal of what we want to get to, rather than giving implicit directions at every step like we will in this Java function. If we go ahead and run this program now, we can see that the value ends up being 3,628,800. And now we're going to switch over to the Java version, which, as we can see, we use another for loop to figure this out, and we're giving implicit directions on each step. We're giving n turns, which in this case is going to be 10, and we tell it exactly how we want it to behave at every single step. If we go ahead and run this, we'll also see that the value is 3,628,800. So they both produce the exact same values. They're just a different method of going about this, and it depends on what you want to do with your program. What you want to do with your program will determine what it is that which language that you want to use. One is good for some things, and one is good for the other. And we hope you've enjoyed our presentation. This has been imperative versus functional languages.